At this point, we are more than halfway through our review of the various solid design principles. So today, we come to the letter I in solid, and this stands for the interface segregation principle. Now don't worry, that sounds really confusing, but it's actually fairly easy to understand. What this principle states is, clients should never be forced to implement interfaces that they don't use. That is the core of this principle. But what exactly does that mean? Well, ultimately, as you'll probably find with all of these principles, it comes back to knowledge, the knowledge that one object has of another object. So why don't we do this? First, let me show you the silly but easy to understand example, and then we will move on to something a bit more real world. So imagine that we are in the world of Star Trek. So we probably have a class captain. Now, what should a captain be able to do? Well, probably they should hire crew members. So what do we do here? Well, maybe we'll just say something like worker, so he can hire them. And then we will do whatever it is necessary to hire that worker. So at this point, think about knowledge. Right now, the captain has knowledge of the worker. Or here's another way to think of it. Because captain is dependent upon worker, that means it is also dependent upon anything that worker is dependent upon. And as you can imagine, that may not be ideal. There's too much knowledge leaking out here. But let's continue on. So we set up our worker. Now, what can a worker do? Well, of course, they can work, and then maybe they can also sleep, just as two quick examples. So now we can call any of those methods directly off of the worker object that is passed into the hire method, or maybe we can call it manage. So when you manage, you have them work, but then you also have them sleep because everyone lives on that starship. So at this point, everything looks good, right? But now, what about when the captain starts hiring android crew members? Well, now that's going to change a little bit because an android doesn't sleep. So you might think, all right, well, I can handle this. I know that I should code to an interface. So you set up one. Interface, worker, interface. Now within here, you specify that yes, a worker should work, and also a worker should sleep. Now we could say class human worker and have them implement worker interface. Now if I were to remove these entirely, don't forget, it'll let me know, hey, you have to conform to that contract. All right, that looks fine. But now we set up Android worker, and he too will implement worker interface. But now we come to this same issue where Android worker has to implement the same methods. So the first method is fine. We could just say return Android working. However, what about sleep? Well, in the human version, we can say return human sleeping, whatever logic would be required to sleep. But now an Android does not sleep. So maybe we just return null because it doesn't apply to an Android. Now, what you see right here, this is what the interface segregation principle is all about. Clients should not be forced to implement interfaces they don't use. And right now, Android worker is being forced to implement the sleep method because remember, if we don't do that, an error will be thrown. So we are having to implement that even though it's functionality that we don't require. This violates the teachings of the interface segregation principle. So how could we improve this? Well, if we follow this principle, instead we should divide this into smaller chunks. Remember, even an interface that contains a single method is perfectly fine. The thing you should be worried about, in fact, is the opposite. We refer to those as fat interfaces. And as you can imagine, a fat interface breaks the single responsibility principle. So once again, these principles are all linked. Instead, why don't we do this? Let's change this to workable interface, and he will just have the work method. Next, we will do another one called sleepable interface, and that will just have the other method. So now human worker will implement workable interface as well as sleepable interface. Now though, an Android worker does not sleep, so he only needs to implement workable interface. Now we can remove that sleep method entirely, and we are now conforming to the interface segregation principle. Now let's come back to our captain. So before, he had a dependency upon worker and whatever dependencies worker had. But now he's not really interested in the specifics, he just wants something that implements workable interface. And now if we wanted to, we could remove the sleep method and this would all work. However, why don't we make a quick callback to the open-closed principle? That states that a class should be open for extension, but closed for modification. So how do we do this? Do we do something like we discussed in earlier lessons, where we say if worker is instance of Android worker, then in that case, we should simply return, otherwise we will have the worker sleep. Is that what we do? No, we've learned by now that more often than not, that breaks the open-closed principle. Instead, what you might think about is maybe saying something like manageable interface. Now, if we were to set up manageable interface, maybe we could have a public function. Why don't I just call it beManaged to be quick? And now, if we come back to Captain, rather than calling these specific methods where it may need to have an understanding of the type of object that was passed, we don't want to do that. Instead, we just want to say worker beManaged. Now, each of these classes can implement that. Manageable interface, do the same thing here. And finally, we implement those methods, beManaged. And now for a human worker to be managed, well, they need to work, and they also need to sleep, and whatever else is required. However, for the Android worker to be managed, they simply need to work. So hopefully that sort of makes sense. It's a silly example, but it gives us an excuse to toy with a number of these principles that we've been learning. The most important thing to understand, though, is now, because the manage method does not depend upon a worker object itself, we have improved the design and reduced coupling. Or, in other words, now our client, which is the manage method in this case, can use any object that conforms to the manageable interface without needing to depend upon any particular implementation of worker. That's the key to understanding all of this. Okay, let me show you a more real-world example, specifically in the Laravel source. And this is actually something that the creator of Laravel, Taylor Otwell, touches upon in his book, Apprentice to Artisan. Definitely check that out. Now, if we access a class called Password Broker, this is what Laravel uses behind the scenes to allow for the built-in password reminders functionality. Now, if we access the send reminder method, notice that we depend upon an implementation of remindable interface. But notice that he called the variable name user. So as you can imagine, we're probably just expecting a user object that we can use to fetch any applicable data from. For example, the user's email address. Now you might be thinking, well, why didn't he just do something like this? Why don't we just depend upon an instance of user? We know that every new installation of Laravel comes with a user Eloquent class, so why didn't he do that? Why not just say, send reminder is going to need an instance of user and be done with it? Well, the reason why he doesn't do this is because now, with this code, Password Broker is dependent upon user. But further, if we switch over to user, we can see that user is dependent upon Eloquent. So, as such, Password Broker is now dependent upon Eloquent. So as you can see, even with a small change like that, there could be big ramifications in our project. And this is what we can refer to as ripple effects. You make some small change in one part of your application, and it ripples over to another part of your application that is dependent upon it. But if we switch back to Password Broker, think to yourself, think about knowledge. Why does Password Broker need to depend upon Eloquent? Why does it need to have knowledge of Eloquent? And the answer is, it really doesn't. It just needs to accept some kind of object that provides the necessary methods. And that's why he type hints remindable interface rather than user specifically. Now, Password Broker doesn't care whether we pass in a user Eloquent object or something else entirely. It simply cares that whatever is passed to the method conforms to the interface. So if we take a look at remindable interface, once again, check it out. It's a single method, and that's perfectly okay. That's the only thing that this method even required. It just needed some way to fetch the email. So if we come down, notice that we call getReminderEmail. If I go back to the user object, notice that it implements remindable interface. So if we scroll down, there it is. This is the only thing that Password Broker really cares about. It needs some way to fetch the user's email. So if that's really the only thing we need, why would we ever make a method depend upon a full object like user, or even Eloquent, which user depends on? And the answer, of course, is, well, we shouldn't. That's simply bad design. So, in closing, once again, the interface segregation principle states that a client should not be forced to implement an interface that it doesn't use. If we were to quickly come back to user, notice how it implements it here? But what if this interface was really big and it had all of these additional methods? Well, it's very possible that one implementation would end up having to create some method and return null because it's not even being used. Don't do that. That violates this principle.